And now I'm going to introduce you to the properties of congruence. It's important to note that these properties of congruence are similar to certain properties of equality. So it's important that we keep them straight. Properties of equality deal with numbers, or properties of congruence deal with figures. The first property of congruence is the reflexive property of congruence. Remember the reflexive property of equality? This is the same thing only for figures. Segment AB is congruent to segment AB, or angle A is congruent to angle A. Any figure is congruent to itself. The next property of congruence is the symmetric property of congruence. This says that if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Same thing applies with angles. If angle A is congruent to angle C, then angle C is congruent to angle A. What it's saying is it doesn't matter which order you say they're congruent in, x equals 4, 4 equals x, only with figures instead of numbers. The third property of congruence is the transitive property of congruence. It says that if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. It also works with angles. If angle A is congruent to angle C, and angle C is congruent to angle E, then angle A is congruent to angle E. This really is an application of the law of syllogism. And the final property of congruence is the substitution property of congruence. If segment AB is congruent to segment CD, then segment CD can replace segment AB in any expression or sentence. And the same thing with angles. If angle A is congruent to angle C, then angle C can replace angle A in any expression. The reason why we're using angles and segments is because those are the only two figures that we've talked about being congruent so far. But these properties work for any congruent figures. So let's try using these. What is the name of the property of equality or congruence that justifies going from one statement to the second statement? In problem number 2, we see we have gone from having 2x plus 9 on the left side of the equation to simply having 2x. So we're missing a 9. How did we get rid of it? Looking at the other side might help. We went from 19 to 10. We subtracted that, didn't we? So that is the subtraction property of equality. And notice how I'm putting the equal sign there to indicate the property of equality. For number 3, angle O is congruent to angle W, and angle W is congruent to angle L. Notice that we're going from basically the hypothesis of one statement to the conclusion of another, because the conclusion and hypothesis of the two statements are the same. It's the law of syllogism, but in this case we know that as the transitive property of congruence. Notice how I put the congruence symbol to indicate that it is a property of congruence. A lot of students ask me, how can you tell which one it is? Well, this is going to be a property of equality. This is going to be a property of congruence. No trick to that, really. And finally, number 4, the measure of angle E is equal to the measure of angle T, and vice versa. Once again, what kind of property are we going to be using here? It's going to be a property of equality. Which property of equality allows us to flip things around the equal sign? That would be the symmetric property of equality. There you have it. You should be able to identify which properties of equality or congruence are being used in these kinds of problems.